layers of ACSR conductor are spiraled in opposite direction. Okay. Now what is this filaments we have in ACSR conductor? We have n number of filaments which are connected in opposite direction. So these are all parallel. Okay. Since each filament has certain inductance L, total what will result in if you have 4 filaments? L by 4. That is, answer is to reduce inductance.
A delta modulator is m of t is equals to 0.1 into t. Delta modulator operate at a sampling frequency of 20 Hz. The optimum value of step size is. So the optimum value of step size is nothing but del by ts is equals to dm of t by dt, which is delta is nothing but a step size, 1 by ts is nothing but sampling frequency, which is 20 Hz here. The slope of m of t is 0.1, hence del of t is equals to 0.1 divided by 20, which is 1 by 200, which is 1 by 2 into 10 power minus 2. So 5 into 10 power minus 3, that is 5 millivolts is the correct option. That is option B is correct.
Effect of corona on transmission line is considered, then inductance, capacitance and resistance are respectively. Okay, we have to find whether it is going to be increased or decreased, these three passive elements. Okay, now what happens if you have a transmission line? Because of this corona is nothing but you have electrons on the surface of this conductor. Because these electrons is nothing but in conducting part, what happens? The effective radius is increased. Okay, that means due to corona we can say effective radius will be increased. Earlier the radius is the distance between this one conductor, okay, from center to circumference of the conductor. Now due to accumulation of the electrons on the surface of this conductor, the effective radius from center to the surface of the conductor, since electrons are conducting parts, is increased. So what happens? We know that resistance is equal to rho L by A. Okay, so this is given as rho L by area is pi r square. Okay, so what happens if radius is increased? If radius is increased, resistance is decreased. Okay, now what about inductance? L is equal to 0.2 ln GMR. Let us take it if we have symmetrical transmission lines. Okay, what is this one? D by R dash into millihenry per kilometer, or you can write this one as 0.2 ln D by 0. R dash is equal to 0.7788 into R. What happens if radius is increased? This is millihenry per kilometer is the unit. If radius is increased, inductance is decreased. Similarly, capacitance is given as 2 pi epsilon naught epsilon r by ln d by r. Since we don't have any self flux concept, or you can say self GMD concept in capacitance, directly it is written as radius r instead of r dash. Now if this resistance, if this radius increases, what happens to the capacitance? Capacitance will be increased. So he asked first as inductance in question, if corona in the transmission line is taken into account, what happens to inductance? Inductance is reduced, capacitance is increased, whereas resistance is reduced. So decreases, increases and decreases is the answer. That is option D is the correct answer.
The circuit shown in figure, the current I is, okay, first of all, I2 is equals to 2 amps. V is equals to I4 into 3R plus I3 into 4R. So I2 is equals to 2 amps, I3 is equals to 1 amp, I4 is equals to 4 amps. So if we substitute V equals to 16R, so I is nothing but 16R divided by 8R, which is 2R. Hence option D is the correct answer.
So the power semiconductor device having highest voltage by current ratings. Next is, can be most effectively paralleled Next one is easy drive and high power capability. Okay, now if you see voltage and current ratings for SCR, it can block an amount of 10 kilovolt, current is around 3.5 kilo amperes. Okay, whereas BJTs it will be around 800 volts and 140 amperes, whereas MOSFET is, the ratings of the MOSFET is around 400 volts and 200 amperes approximately. Okay, so the highest voltage and current ratings will be out of these three for SCR. Now, which of the following device is going to be most effectively paralleled? Okay, if you see for SCR, we have negative temperature coefficient. Similarly, for BJT, we have negative temperature coefficient. So, MOSFET is having positive temperature coefficient. What does it mean that? Okay, positive temperature coefficient, that means as current increases, resistance is going to be more. Okay, that is what positive temperature coefficient. So, MOSFETs are having positive temperature coefficient so that it can be effectively paralleled out of these two. So, first one is SCR, second one is MOSFET. Now, what about the last one? Easy drive and high power handling capability. Okay, IGBT will have, because IGBT is nothing but BJT plus MOSFET. That's why these are going to use in practical applications in most. Okay, IGBTs, because MOSFETs will have high on-state and conduction losses, whereas SCRs will have negative temperature coefficients. Okay, MOSFETs will have less on-state conduction losses, whereas SCR will have power losses. Okay, this mixture means here BJT and MOSFET combinedly, the advantages of BJT plus advantages of MOSFET will come into picture for IGBT. That's why it is going to be used in most in drive applications. So last one is IGBT, SCR, MOSFET, IGBT. So option C is the correct answer. These inverters is most suitable for, okay, always series term refers to voltage, parallel term refers to current. When more number of inverters are connected in series, what happens? Its voltage rating is increased. So you can say that directly it is having high voltage. Since these are connected in series, what happens? The load, current flowing through the load is always low current. Okay, so high voltage and low current, option A is the correct answer. For suppose if you have parallel inverters, parallel refers to currents. Okay, so we can say that if you have parallel inverters, we can say that we have high current, but whereas voltage is low. Okay, this is for parallel inverters, whereas this is for series inverters. So option A is the correct answer.
Value of the determinant ABC, M and P and XYZ is given as K, and we have to find the value of the determinant 6A, 2B, 2C, 3M, N, P, 3X, Y, Z. Let us use properties of determinant. Now what I do is I'll take 3 common from the first row, so which can be written as 3 times of 2A, M, X, 2B, N, Y, 2C, P, Z. Similarly, we can take 2 out of first row. So 3 into 2, then it will be A, B, C, M and P, X, Y, Z, which is nothing but 6 times of K. That is option D. You have to find the probability of guessing 6 questions out of 10 in an examination if each question consists of 4 options. So if each question consists of 4 options, there will be only one correct answer. So probability that the answer is correct is 1 by 4, and the probability that the answer is wrong is 3 by 4. We have to select 6 questions out of 10. So the total number of questions are 10, and we have to select 6 questions. Exactly 6 or more. So we have to check P of x greater than or equal to 6, which is 10C6 into 1 by 4 raised to the power of 6 into 3 by 4 raised to the power of 4 plus 10C7 into 1 by 4, 7, 3 by 4 cube, plus similarly 10C8, 10C9 and 10C10. 1 by 4 raised to the power of 10, 3 by 4 raised to the power of 0. If I simplify, the value will be 0.09, which is option B.